All right, welcome to the first standard remediation ed puzzle. We're looking at solving linear equations and inequalities. So basically, I'm going to work through some problems, say some other things about it, and then there'll be some questions embedded, followed by the assessment at the end of it. There'll be a link for. So I'm just going to work these out, and Ms. Williams is here in case she wants to add any commentary or ideas or anything she's told her classes, which would be great. So let's just jump right into it here. All right. It says solve, so that means your answer is going to be x equals something. And you just want to get all the x's to one side, everything else to the other side. So let's do that here. I'm going to move this x over here, and we talk about flipping it. That's kind of the terms I like to use. Flip it over here, it becomes negative. So that gives me 4x on the left side. Flip the 12 over here and get negative 16. Divide both sides by 4. Or think about undoing. We're undoing 4 times something. So undoing, opposite of 4 times something, is divided by 4. So x equals negative 4. All right, here. So we want to talk about rewriting. We talk about these methods we have in class. Like in this one, I'm going to rewrite by distributing that 2. So it gives me 4 minus 2x. So that's a method of solving called rewriting. And then we've rewritten it to where we can kind of treat it like that last one up here. And this is an inequality, but I'm just going to ignore the inequality for now. Go ahead and do it like I did this last problem up here. So let's see, I'm going to flip the 3x over here. So that gives me a positive x. And then I'm going to move this negative 4 over here. And that gives me what? Negative 6. And there we go. So we didn't really have to worry about the inequality. And real quick, for what we're doing in class right now, that would be a number line filled in circle at negative 6. And x is less than, so we'd shade to that side. But we don't have to worry about that here. That would be for what we're doing in class now. All right, solve 5x minus 10y equals negative 40 for y. So obviously, this one, you can't get an answer. There's only one equation with 2 variables. But we can solve for y, meaning get y by itself. That's kind of the terminology, y by itself. So I'm going to write it over here. So again, we want to get the y by itself. Think about undoing. Like right now, the y is not by itself. It's kind of crowded in with all this other stuff. So think about undoing things so that y is by itself. Like what's the opposite of 5x? Well, that would be minus 5x. So I've just gotten rid of that. 10y equals negative 40 minus 5x. Now, so ask yourself, is the y by itself? No, it's not. It has a 10 there, a negative 10. So what's the opposite? All right, so what's the opposite of times negative 10? Divide by negative 10. Be careful, you got to divide everything by negative 10, though. So we get y equals negative 40 divided by negative 10 is 4. Negative 5x divided by negative 10 would be plus 1/2 x. Does that look like any of our answers over here? Yeah. Cool, moving forward. All right, yeah, here's another opportunity for rewriting. We don't really like fractions when it comes to solving things. It makes things a lot more difficult. Some of you might be tempted to cross multiply, and I get that. But what I'd recommend, it might have the same effect, is rewriting by multiplying everything by 4. That's rewriting it. It just gets rid of those fractions. So multiply everything by 4. Those cancel. Those cancel. We get 2x plus 3 equals x. So let's get all the. Let's get this. Flip this 2 over here. Get 3 equals negative x. Now again, your x is not totally by itself. It has a negative in front of it. So by negative 1. That's why we do that. By negative 1. Oh my goodness. There we go. So x equals negative 3. All right. And just, I'm going to pause on this one and address how you could be checking your answers here. This is, I think, a good one to do that on, just because fractions are kind of wishy-washy for some people. So if I take that negative 3, put it into this x right here, and into that x right there, it gives me 2 times negative 3 plus 3 divided by 4, which that's negative 6 plus 3 over 4, negative 6 plus 3 is negative 3 over 4 equals, and if I put the negative 3 right there, that equals negative 3 over 4. Good. So never hurts to go check your answers. Number 5, let's see, formula. Solve the formula for b, so that means get the b by itself. So let's do that. 1/2 bh. Right now, the same thing. We're just going to talk about undoing stuff. So how do you undo something times h? Divide by h. So I'm going to divide both sides by h. Those h's cancel. Now I'm left with a over h equals 1/2 b. Okay, how do you undo times 1/2? Well, that's the same thing as dividing by 2. We could just rewrite this like that. Well, how do you undo divide by 2? You multiply by 2. So multiply both sides by 2. So again, it's that process of undoing. What's the opposite of whatever's happening? And b equals 2 times a over h. Now let's see if that matches up to something we have over here. 2a over h, like that. Now careful, that's different than this one. The 2 is in the 2 is in the bottom here. It's in the denominator here. So that's a different, that would be 1/2 instead of 2 times. So just be careful on that. All right, that's a little word problem here. 7 charms for 31.50. Each charm costs the same amount of money. Write an inequality used to find the maximum amount of charms making them combine with $75. So let's see. We should have 7 charms for 31.50. Let's see. So we could say like, oh, it says C. Okay. So she can only spend $75, so I'll put like $75. She can't spend more than that, so however many she buys or however she spends has to be less than or equal to that. That's a good place to start. 75 is the most she has. So whatever is over here cannot be bigger than 75, so it has to be less than or equal to 75. And let's see, it's the same. Oh, so I guess we need to figure out first, let's see, 7x equals 31.50. So that will give us the cost of each one, individual one, right? So if I divide that by 7, x equals, over here. So each charm is 4.5 or 450. So it's just 4.5. That's the number. That's the cost of each one times the number of charms, and that's it. It's right over here. So $75 is greater than or equal to, and that's the most we can spend, 450 times however many charms she buys. Oh, and then what is the maximum amount? Well, let's just, so with the we got to solve our inequality. And 75 is less than or equal to 4.5 C. So let's do 75 divided by 4.5. So now that's a, let's see, that's a decimal, 16.66666. So she can't buy like 0.6 of them. So I think we just say she can only buy 16. She can't buy 17. So even if she has a couple bucks left or a couple cents left, so not $16, just 16 is the most she can buy. Solve the inequality below for x. So same thing. I'm just going to ignore that it's an inequality and treat it like it's an equation. So I'm gonna, let's get the. Oh, here's an opportunity to rewrite as well if you wanted to. I wonder if this might make this one easier. I don't know. Multiplying by 4. Yeah. Okay. Let's do that.
Always get rid of your fractions.
So multiply everything by 4. This becomes 3x plus 8 is less than or equal to 12x minus 4. Yeah, so no fraction now. A little bit bigger numbers, but that's okay. So let's subtract the 3x, move that over here. And then I'm going to add this 4, get it over here. Yeah, okay, so 12 is less than or equal to 9x. Divide both sides by 9. And you get x is greater than or equal to. So you divide, that's a fraction, so you divide both by 3 and you get 4/3. So x is greater than or equal to 4/3. Now, I've had some conversation with students who get worried about the inequality being flipped here, but it still means the same thing. X is greater than or equal to 4/3. It's the same as 4/3 is less than or equal to X. So it doesn't really matter which way the inequality is going, as long as it's going to the right, the right symbols. Now this is what's called a compound inequality. There's a little more space for this one here. Oops. Good. All right. So in this one, like you got to flip the 3, except that there's basically multiple inequality signs and multiple equal signs. So you're going to subtract 3 from everything. And the goal is still just to isolate X here. Just like it was over here, the goal is still to get X by itself. So we're still thinking about undoing. There's a +3 here. What's the opposite of +3? -3. So I've done 1 -3 over here. That gives me -2. So let's equal 2. Let's cancel. -9 minus 3, that's a -12. Is this equal to -2x? Let's see. And, well, -2x, the x is not by itself yet. We need to undo, and that's by getting the -2. Divide by -2. So divide by -2. So that gives me, that's a +6 less than or equal to x is less than or equal to 1. Now, there's this thing with inequalities that whenever you divide by negative, you have to flip the inequality signs. Now, this is a compound one, but I think we still have to do that same rule. So when I do that, I get 6 is greater than or equal to x, and then x is greater than or equal to 1. That's kind of awkward, but let's see if it matches up. Yeah. I don't like that problem. I don't like the way that they wrote that.
It's also true if they multiply by a negative, they have to flip their inequality sign.
Yep. Agreed. Yeah, multiplying is the same as dividing. So, yeah, I don't like the way they wrote that though. X is less than or equal to 6. It's just, I don't like it. Okay. Tony works at a bike store. Tony earns $300 every week, plus $15 for every bike that he sells. Inequality can be used to determine the number of bikes Tony must sell in 1 week if he wants to earn a minimum $500 for that week. So, like $500, he's saying needs to be less than or equal to whatever he gets over here. I guess I like starting inequalities that way. A minimum of $500. All right. So how much money he makes? $300 a week, plus 15 for every bike. Now, do they? Yeah, they give us B for bikes, so we'll use that. Plus $15 for every B. And this is dollars. This can help keep it straight when you're writing these things. 300 is dollars. 15 is dollars. Those are a consistent unit there. B is in bikes, though. It's like you've got that's the other element. So I like when I write these things, thinking about that. The number of bikes he must sell in 1 week, he wants to earn minimum. So I think that's it then. This represents how much money he's going to make. 300 plus 15B. So 300 plus 15B. Oh, sorry. Oh, no, it's fine. Where it is. What is the minimum number of bikes? Yes, so let's see. Let's just solve this. 500 less than or equal to 300 plus 15B. 300. So yeah, 200 is less than or equal to 15B. 5 by 15. Undo the 15 times something, you could say. Yeah, I can't do that in my head. It's what? I don't want to mess up. So that ends up being about 13.333. But again, you can't sell a third of a bike unless you're junking it or selling parts of it. But we're not going to get into that. So B is greater than or equal to 20 over 15, which is about 13.333. But you can't sell a third of a bike. So we'll just say the answer is 13 then. 13 bikes. Cool. Okay, so we've gone over all these problems. And then you'll see the link here at the end, and then you will go take it and show your mastery skills of this standard, which was called Solving Linear Equations and Inequalities.